Hello, this is mathjazz from Almost Cool. Today I am going to do a small tutorial on how to set up LaTeX and a little bit about how to use it. We'll do more complicated stuff in future videos, but this is just the very basics, starting with downloading LaTeX. So you're going to want to go to mictex.org. It's MIKTEX.org. And you're going to want to download whatever version of mictex is going to match your operating system. So I have Windows, Mac, and Linux, and I guess whatever Docker is. Well, anyway, so download whatever you need for your computer. mictex is not just a LaTeX typesetter, but it's also it contains TeXworks. So it's completely capable on its own of typesetting LaTeX code, so you can use this by itself. However, I like TeXmaker to edit my LaTeX documents. So if you want to use TeXmaker, you type in TEXMAKER into Google, and it will take you there, or to take you here, and you can download that. I'm going to be using TeXmaker for this tutorial. So once you've downloaded both of those, then usually you don't want to try writing your own LaTeX document from scratch when you're just learning. You'll want to download some sort of template that's similar to what you're trying to make, and then alter that until it becomes what you would like it to be. I have a template here that I will link in the description below, and I'll also give you links to these two supporting files that must be in the same directory as your TeX code. So this homework1.tex is the actual TeX code. These are two style files, STY files, that are needed to get this to run, and in a future video we'll show you how to download other style files in the case that you need them. So you're going to open this up using TeXmaker. Oh, on my other monitor, here it is. So we use TeXmaker and we get this. And so on the left side is your code. On the right side is the output. Beginning of every LaTeX document, there is a document class command, usually followed by a few package commands. Don't mess with these for now. We'll get to those in another video. After that, you have a whole bunch of commands that you can build yourself. We'll talk more about commands in a future video, but this is probably the simplest command that I have here. It's new command /inv. What this does is this command, new command, takes in two things. The first thing is the name of the command that you're creating, and the second thing is what that command does. This is a very simple command. All it does is it turns \inv into a superscript -1, so a -1 in an exponent. And I use that a lot, and I find that it's nicer to type /inv than it is to type caret open curly brace -1 close curly brace. It's just a little bit faster for me. That's why I use it. But you probably shouldn't mess with these until you are more secure in your feelings for how to do LaTeX. Except for maybe writing very basic commands. We'll get into harder things like these commands make absolute value bars, and those are useful to have. Okay, so this part you'll want to change in this template. You'll want to put your name, the class that you're in, and the homework assignment that you have. Those will change the header of the document here. This is the name, this is the class number, there's a little pound symbol hashtag that will be placed here, and then whatever number of assignment will go here. So like if this is the 10th assignment in the class, then it'll say number 10. You don't have to compile after every edit that you do. Sorry, this button here is the typeset button, or the compile button is what I'll probably call it. And what it does is it takes all of this code and actually executes it and creates a PDF document. You can see on the right. So once you've typed in this, you come down to this section here. This is going to be your actual list of problems and solutions. So these begin and end problem tags. Between the two of those, you'll want to put your problem. Inside of these square brackets, you'll want to put the problem number. So if this is like problem chapter 1, section 2, number 7, then 1.2.7, when we compile, it'll become problem 1.2.7 there, or whatever you want to put here. So just put in your problem number there, and it'll put your problem number there. Okay, so I have this one already finished. So this is the problem. It's going to prove that square root 2 is irrational. So this command here, sqrt, so /sqrt, it takes in an argument. That's the thing between these curly braces. Whatever is between the curly braces will end up underneath the square root. And it doesn't have to be a number. You can put in even words. All it knows, it doesn't care what you're writing, but it'll just take whatever you've written in between those two curly braces and put it under a square root sign. Now, square root is a math mode command. So it has to be done between two dollar signs, which are inline math mode. Notice that this math is inside the sentence. That's called inline math mode. And you go into inline math mode by using dollar signs. Or the square root function can be between these /square braces. That gives you what's called offset math mode or display math mode. So, and display math mode is probably the more common name for this. But all it does is it takes whatever is between your /square braces and it puts it indented or centered and outside of the normal sentence. So suppose that square root 2 equals dfrac pq gives you this pretty equation here. Square root is on the left, there's an equal sign, and then dfrac is a command that takes two arguments. The first argument is going to be your numerator, the second argument is your denominator, and again, it doesn't matter what you put in there, it just shows up in the numerator. Oh, one important thing to note is that math mode does not care about spaces, so it will take all of the spaces out of your sentence if you type something. There we go. And that's because most math doesn't have spaces in it. When you're writing out something in math, it doesn't usually have a space. If you do want to put a space, there are ways to make it like \comma will make a space. Or you can do /text and type a space. So /text is a way of putting text in the regular font inside of a math mode. Environment. So notice that normal font is normal because it's inside of a text command and everything else is not. Okay, so anyway, getting through the rest of this proof, suppose that square root 2 is equal to p over q, where p over q is in reduced form, then that means that 2 equals p squared over q squared, which implies that 2q squared equals p squared. So this command here, right arrow, or capital R right arrow, gives you a double stroke right arrow, which is usually used in math to say that the left side implies the right side. The left side being true means that the right side must be true as well. Again, here are the slash commas, the backslash commas that give you spaces, and that gives a little space between this first equation and the double stroke right arrow, and between the double stroke right arrow and the second equation. But 2q squared equaling p squared implies 2 divides p. So we let r be the number such that 2r equals p. Then we get 2q squared equals p squared equals 2r all squared equals 4r squared. So 2 divides q, but that means p and q share a common factor, namely 2, which is a contradiction. We said p over q is reduced. And getting that contradiction means that our last assumption made must have been false. Well, the only assumption we made is that that square root 2 is irrational. So, that square root 2 is rational. So therefore that is false. Square root 2 must therefore be irrational. There's the proof. Okay, so that is some basic code and how to kind of like work through it and how it works. Let's do another problem. I'll do it entirely from scratch now. So we're going to say compute the integral. And integrals are almost always prettier in offset mode, so we'll do that. The command for an integral is /int. Let's do from 0 to let's do 1 plus x. Now, underscore in math mode means the next object taken is going to be subscripted. And caret means that the next object is going to be superscripted. Curly braces mean whatever's inside the curly braces is treated as one object. So right now, what we have written is we'll have an integral swoosh, a subscript 0, so a lower limit of 0, and an upper limit of 1 plus x. Okay? And we're going to integrate t with respect to t. We get this. Now, if you like having dt in the regular math font, then this is fine. If you don't, you can give it put it in a text box and it'll come out in a straight dt. That's your choice. Or I guess if you really wanted to, you could put just the d into a text. So now you have the d is vertical and the t's are italicized. But that's stylistic things that you can do on your own. I actually kind of like how it looks right now. So we'll leave that. And this is our problem. So solution, we'll just do an offset math mode. So we have the integral is equal to, well, what's an antiderivative? It's going to be 1/2 t squared. So have defrac t squared on the top. If you hit tab, it'll go to the next dot when you have a multi-part command. So like if I'm just somewhere over here and I hit tab, it'll jump to the next spot that I need to fill in. So that's our antiderivative. It's a fraction with t squared on the top and 2 in the bottom. And then we want to have an evaluation bar. So this is how we want to do an evaluation bar. On the left side of our fraction, we'll type left. This means that there is some symbol that we want to make as tall as the fraction that's in between our left command and our right command. Okay, so this is how we make like evaluation bars that are not short and funny looking. Actually, let's make the funny looking one here just so that we get an idea of what I'm talking about. So we want to evaluate. So here's our evaluation bar from 0 to 1 plus x. If I compile this right now, I get this funny little short evaluation bar that looks really silly. I don't want that. I want the evaluation bar to be as tall as the fraction on the left side. So I'm going to put a left command on the left side of the fraction and a right command on the right side of the fraction. What this will do is it'll say everything between left and right, I want the symbols that are attached to my left and right to be as tall as the stuff between the left and right. Now, attached to the right side, I have this vertical bar, and that's what I want to have be as tall as my dfrac. So this is going to take this vertical bar and stretch it out to be as tall as this fraction here. On the left side, I don't want a symbol. I mean, if I wanted to, I could put a parenthesis and that'd make a tall parenthesis, or I could make a square bracket and that'd make a tall square bracket, but I don't want anything at all on that side. So putting a period says, don't put a symbol on the left side. So if I compile this now, I get an evaluation bar that's as tall as my fraction, but I also don't get a symbol on the left side. So this is what I would like. And then to finish the problem, we plug in, of course, our top limit is going to be the 1 plus x. So let's get our command here. Copy that. And we want 1 plus x. And then we will subtract the same antiderivative, but we plug in 0 this time. And we'll simplify that as well. That's going to be 1 plus x. There we go. And now we have our solution. So, and it looks very pretty. It's so much cleaner than writing it by hand for most people. I mean, there are those of you that have good handwriting out there, and I acknowledge that, but there's, even if your handwriting is really good, the benefits of typing mathematics are you can email this to your grader and it gets timestamped so that they know it wasn't late or it doesn't get lost. You have a copy on your own. You can keep all of these. I have homework from years ago that's just kept in PDF form, and I can always go back and look at it and refresh my mind if I remember, oh, you know what, I forgot what the Selov theorems are. And I just really need to go back and look at the homework I did for Selov theorems in that math class from 5 years ago. Okay? I promise you I do remember the Selov theorems. But as an example, I can go back and look at those. And I can look at my homework and it's there. And it's not like all of the homework I've done for all of graduate school is digitized, so I don't have to carry a physical copy of it, but I can still look at it whenever I choose. And it's really valuable, and I highly recommend developing your LaTeX skills now so that they'll be useful to you in the future. Anyway, have a great day, YouTube land. We'll see you next time. If you have questions about LaTeX, put them in the comments below, and I will get to them. So, bye! Oh, wait, before I go, one last thing, actually. I want to show you detechify. So, if you are stumped, you don't know the command for a particular symbol, you can go to detechify. That's DETEXIFY. And you can draw the symbol, and it will tell you the code for that. So, like, let's say I want a plus sign with a circle around it. And now it's taking forever. There it goes. Okay, so it says that the symbol is O+. So let's just check to make sure that detechify isn't lying to me. So let's do just O+, and there it is. Look, it's a pretty little O+ symbol. So if you are looking at a symbol and you don't know how to draw it, then you can do that. You can look it up on detechify, and it's really good. Anything that's harder than that to stump you, maybe go to there's Stack Exchange is another great site for trying to figure out how to get LaTeX to work for you. Capital L, lowercase a, capital T, lowercase e, capital X. That's how you type LaTeX. So LaTeX Stack Exchange is also a great source of help. So you can go here and It'll tell you all kinds of really interesting things, how to fix problems. Okay, so now YouTube land. Thanks for watching. See you next time. Bye.